Hey guys, these notes are for domain and range. We are in Unit 2. Our essential question is, what do domain and range tell us about our data? So previously we learned about continuous and discrete representations, and so we determined whether they were a function or not and whether they were continuous or discrete. We also listed their domain and range. Now with discrete and continuous data, there's a difference between listing the domain and range for both. For example, for discrete, you're going to be listing your values. So just to remind you, our x values are going to be our domain, so our domain are our x values, and our range are our y values. So when we have discrete data, we list our values out. List the values. And when I list the values for discrete, domain, and range, I use little curly braces, or little squigglies, as we sometimes call them, and you list the numbers between those curly braces. Now for continuous, it's a little bit more complicated. However, domain is still x and range is still y. Okay, now with domain, you could have a multitude of possibilities, but you know that you're going to have inequalities because it can be a range of numbers, not just a list of numbers. So for domain, we know it's our x values. We could have less than or equal to signs on both sides, or we could just have less than signs. And if you're confused on when you have less than or equal to, please refer back to the notes for the previous lesson, because if you don't know the difference, it's going to be really challenging for you to be able to do continuous domain and range. But you could also have a mixture of these inequality signs. You can also have less than or equal to and less than, or less than and less than or equal to. Now you're probably wondering, why do we always have less than signs? Well, the way that we learn how to write domain, we always want to start from the left to the right. So we're always doing our smallest values to our biggest values, and so that way it's always consistent and we always have less than signs. It's also a lot easier to have not so many things to remember, because if we're thinking about a bunch of ways we could write our signs, it can be a little bit of an issue. All right, so y values, we could have a multitude of these inequality signs as well, and it just depends on our data. Okay, and then I showed you guys this neat little thing called Dollar Robot, and this just tells us how we're going to look at domain and range. So for Dollar, we're talking about our domain, and we're going to be looking at our data from left to right. For Robot, that's going to be our range, and that's when we look at our values from bottom to top. Okay? All right, number 1. So we're given a table here with time in minutes and height in inches, and we're asked to find the domain and range and whether it's continuous or discrete. But I do want to talk about something really quick. When we're talking about x values, right, so our table doesn't really give us an x or a y value for our table, so we got to figure it out. Well, our x values are always independent, and we learned this in science class, but it's the thing that doesn't depend on something. It will be independent, and it will move on no matter what's going on with the other variable. That means our y variable is going to be our dependent variable. So for number 1, when we have time and height, which one of those is going to be independent, or our x value? Well, time is going to be independent. Time is never dependent on anything, so that's going to be our x value, which is going to make our height our y value. Okay, so our x side is our time, and the y side is the height. Now for domain, we want to, well, let's talk about domain and range. Are we going to list values, or are we going to write inequality signs? Well, first I have to ask myself, is this continuous or discrete? So remember, discrete is something that you can only have whole things of, and usually when we're talking about graphs or data for math, that's going to be isolated points. And then for continuous, we're allowed to have halves of those things, and for graphs, we're looking for a continuous line, so something that I can draw and connect everything with a line. Now, if I look at my table, this is essentially giving me 5 random points, 5 isolated points. Like I have 5, 132, I have 9, 149, I have 12, 182. So these are actually 5 isolated points on a random graph somewhere. So since these are randomly isolated, this is going to be discrete. And when my domain and range is discrete, then it's a lot easier for me to write it out, because all I have to do is list. Just a reminder that domain is x. And since it's discrete, we just list our values. So we're going to list all of the values in our x column: 5, 9, 12, 18, and 20. And I want to put commas because I want to make sure that, hey, we're separating these numbers, or else it'll just look like one really big number. Our range are our y values. So I'm going to list all of my y values out: 132, 149, 182, 213, 252. Oops. All right. And that's it for number 1. Number 2. So number 2 and 3 are very similar, just because I wanted you guys to get some more practice with this. But if I look at number 2 and 3, they're very similar. Now, we haven't seen a representation like this before, but this is called, these are just ordered pairs. So if I look, this first one is an ordered pair, and this is an ordered pair. And we also know them as coordinate pairs or x comma y, but these are all ordered pairs. So just to remind you, ordered pairs have the form x comma y, so your x variable goes first and your y variable goes next. So since I noticed that these are just 4 individual points, then I'm going to put discrete because they're just isolated random points. They're not continuous anywhere. So that means we're going to be listing our domain and range. Domain is x values, so I'm going to go ahead and highlight all of my x values so it makes it a lot easier for myself. 3, 2, 5, and 6. Just remember that in the ordered pair, your x value comes first. So we're going to have 3, 2, 5, and 6. Now on a star test or on a normal test, if they give you the choice to list this domain out, they're going to put it from least to greatest. So let's go ahead and practice writing these numbers from least to greatest. So I have 2, 3, 5, and 6. Now is the first way wrong? Not really. But you will be seeing it as least to greatest a lot when you're not writing it and when either a test is writing it or I'm writing it. Your range is your y values, so I'm going to highlight all of my y values. -1, 4, -8, -7. So I'm going to go ahead and list this, -1, 4, -8, -7. Or, let's do this from least to greatest. Our least value is -8, then -7, -1, and then 4. All right, number 3 is exactly the same, so if you'd like to pause the video and kind of figure this one out on your own, that would be awesome. I'm going to go ahead and begin. So I noticed that this is just like number 2, so I'm going to go ahead and circle discrete because I know it's just random points, and in this case I have 3 of them. Now for domain, that's going to be our x values, and since it's discrete, I'm going to list again. Highlight all of my x values here. But I want to list them from least to greatest. So these are all of my domain values. Then I'm going to list my range values, which is all of my y values. Oof. And again, I'm just doing it least to greatest because it is something that we want to get used to seeing. All right, number 4. So here we're talking about days and books sold. And this is just a graph with a bunch of random points on it. Because it's a bunch of random isolated points, this representation is also discrete. And so here I'm going to list all of my x values in my domain and all of my y values in my range. But before I do that, I'm going to go ahead and list all of my points out just so I can be sure what my x and y values are. And you don't have to do this if you see it, but I would like to list out all of my points. So this is the point 1, 3, 2, 5, 3, 1, 5, 4, and 1, 6. Now again, sorry, not 1, 6, 6, 1. Whoops. I'm doing this just because it helps me visualize a little bit better, but if you can do it without plotting all your points, then that's awesome. So again, we're going to be listing our values here, so I'm going to highlight all of my x values. And I like to go from least to greatest, so I'm going to start with 1, 2, 3, 5, and 6. And then all my range values are going to be all of my y values. So I'm going to highlight all of those. So I have 3, 5, 1, 4, and then I also have 1 again. Now it's not going to be wrong if you list 1 again, but you also don't have to list 1, and I'm just not going to. It's just kind of a waste of time for me, so I'm not going to do that. And I'll go ahead and list this from least to greatest. All right, number 5. Now this one's a little bit different from the last ones we saw. This is still a graph, however this is a solid line. And since it's solid and all connected, this is going to be a continuous function, not discrete, because it's not broken, it's a whole graph. So when I'm talking about my domain and range, it's going to have inequality signs. Now since my domain is my x values, I'm going to go ahead and put an x in the middle. And I want to look for domain when I'm going to do left to right for dollar. LR. So I'm going to go on the left side first on my x values, and on the very far left I have a closed circle, so I know it's going to be less than or equal to. Remember, closed circles mean we have equal to. And then the number that's going to be on that side is going to be -1. And then on the left side, or on the right side of my graph, because we're going L to R, I notice I also have a closed circle on my right side. So I'm going to have a less than or equal to, because closed circles are equal to. And it's going to equal at positive 2. For my range, it's going to be exactly the same, except we're going to have our y variable. So you want to go from bottom to top for this one like robot. So from the very bottom, I start with -3. And that's a closed circle, so this will be less than or equal to. And if I go all the way to the top, I'm at +3. And that's also a closed circle, which will mean I have a less than or equal to. But that is it for our notes for domain and range. There are a couple of word problems in your homework, but if you need any help, please feel free to come in and ask.